This is the Internet Report, where we uncover what's working and what's breaking on the internet and why. I'm Mike Hicks, Principal Solution Analyst with ThousandEyes. I'm joined today by Kemal, Principal Internet Analyst at ThousandEyes. Welcome, Kemal. How are you going?
Thank you, Mike. It's good to be back on the Internet Report. Thanks for the invite.
It's great to have you, mate. Always good to chat. Today, we're going to unpack the recent Quad9 BGP incident. And Quad9 is an open DNS recursive service that replaces your default ISPs or enterprise DNS configuration. And why is this important? Well, when your computer performs any transaction that uses DNS, and most of them actually do as we go through from there, Quad9 effectively looks up and blocks the malicious host names. So it's obviously quite important if we actually sort of have an incident going across from there. So with that, let's dive in.
So yes, Mike, what really happened is that we got reports of large spikes in packet loss when it comes to Cloud9's service, right? And it looks like it affected several different large-scale ISPs or tier one providers, for that matter, such as Verizon. And as you can see on the shared screen, we have path visualization, ThousandEyes path visualization, which essentially shows three different agents: Dallas, Texas, from the perspective of Verizon, Chicago, Illinois, from the perspective of the Verizon as well, and Los Angeles, California, also from the perspective of Verizon. Now, Verizon is tier one provider, like they are quite big and large, but you can quite clearly see that somewhere around 12:15 UTC on Monday, December the 12th, there was a significant spike in packet loss that actually went on for quite extended period of time, and it ended approximately around 13:40 same day. However, as you can see, like when I'm hovering over the path visualization spike of the packet loss on the timeline, we are showing average values across quite large number of the agents that are assigned to this particular test. However, if we focus on, for example, on Chicago agent, we will see that actually the impact was quite significant. So from the agent drop-down list, if I type in Chicago,
and I just on that point, what we're saying there, Kemal, is that when we're looking at this view here, we're looking at a percentage there. Because that's averaged out across all the agents, it's essentially showing a low percentage. But now when you've gone in Chicago, we're seeing it sitting up 100%. So, yeah.
Exactly. Like you can quite clearly see that it was going to 100%, 90-something%. And, it was pretty significant. Now with the dark red color, we are seeing Chicago, Illinois agent actually having this large spike. And the same pattern goes for these other two agents in Dallas and Los Angeles too. However, just before the event has started, so we are looking at the data point at around 12:10 UTC on December the 12th, we can quite clearly see that the path that we were taking goes from the Verizon, and then, down the line, traffic is still with Verizon, and ultimately, somewhere down the path, they actually hand over traffic to Telia, which is, again, one of the tier one providers, autonomous system 1299, before the traffic reaches 9999. Right. On the other side, when it comes to Chicago agent, we can see exactly the same pattern, except for the fact that actually traffic went to level 3, again, tier one provider with the autonomous number 3356. Right. So when the event has started, if we navigate towards the a loss on the path visualization, you can quite clearly see that even at the very start of the event, the packet loss spiked to 92%, which is pretty significant.
Yeah.
If you look at
and I think that's also quite significant because it was almost like a light switch that we see we go from 0 or low right up to that 92, 95, which is turned on, turned off. So.
Exactly. Like it's going to have a profound impact on whatever the service on the other side is. In this case, we know that's a DNS service, but as you can quite clearly see, like essentially what really happened is that, there was a lot of impact. And looking down the path, you can quite clearly see that on the path visualization, there were certain changes in the path. All of a sudden, like you can see that traffic is all combined from all of these three agencies going through the France Telecom or Orange. And even further down the line, you can see that actually autonomous system 3844 which is Liquid Telecom, essentially starts dropping pretty much all of the traffic. Now, it's quite interesting to see that, Liquid Telecom, which is based in Congo, actually attracted this traffic somehow, right? Now, even before we start speaking about that, there are two things that I want to touch base. First one is this purple line. Mike, can you tell us a little bit about what these purple lines indicate on the path visualization?
Yeah, that's interesting point. So when we're seeing the purple lines, what we're saying from that is we're looking at a network outage, but this is coming to us from our collective intelligence system. So this is where we're putting the test together and we're picking it up within Internet Insights to actually say there is some sort of picked up on a global perspective because impacting sort of multiple people there.
Well, okay, thank you for providing more context into that. So I think the next interesting thing is actually to see how this event or how this spike in packet loss actually, what is the effect that it had on the DNS server itself. So if I click on the views for DNS server, while Chicago, Illinois agent from the Verizon's perspective is selected, we can quite clearly see, availability dips 100%. Like before the event, essentially availability was 100%, and during the event, essentially the core function of what the test is doing goes to 0%. There was intermittent spike in availability where it essentially kind of recovered, but again, for a complete duration of this event, essentially the test was not able to do its job. And what it's doing is, we are trying to resolve target domain of example.com using UDP for the A record using Quad9's DNS server for you, which provided already description for. So the next question, I guess, Mike, is what really happened?
Yeah, sorry, before you dive into that, can you just explain a little bit there, or expand a little bit? We're talking here about a DNS server test. So we're actually, and I think you've covered it just briefly there, but a little bit of, why this is important than just a reachability. So if we were looking at an HTTP server test, we might see a DNS failure, but this specifically tells us we're looking at a DNS server. Is that right?
Yes, that's correct. So essentially, why is this important? DNS server stands for domain name system, or domain name service, right? And it's actually the function of this particular service is to translate domain names to IP addresses, right? So what happens is whenever you type in google.com into your web browser, or whenever you type in any domain name for that matter inside of your web browser to view the page or get your resource or something like that, one of the first things that's going to happen is essentially translation of that domain name into the IP address. Our computers unfortunately don't understand the concept of domain names like google.com, ThousandEyes.com, Cloudflare, or Quad9 for that matter does not really mean anything to our computers, but IP addresses that are behind these names means everything, right? So in order for a computer to establish a connection to that resource, it needs to translate it, which is essentially what it does.
Good, like the zip code. And my computer understands. I shout loudly at it and it understands.
Fantastic. So now, we saw that on the path visualization, there was this pretty much profound impact on the packet loss, right? From the packet loss perspective, as part of which packet loss really did spike quite a lot, and it caused the fundamental functionality of the test itself to completely fail, right? Now, for that matter, like essentially all the people that were using Quad9 as their DNS provider during this particular time that were affected by this. So, for example, all of these users in Verizon, for example, would have a problem translating their domain names to IP addresses, as part of which essentially they would not be able to use the internet, right, for that matter. So, but the real question here, Mike, is essentially what happened here. So if we click here onto the BGP route visualization, we can see that there were two different spikes in the path changes. So there was the one that happened here approximately at 12 o'clock, and we're going to get some more details about it. And then there was the one that probably was done just at the end of the event itself. But let's dive into what actually happened here. On the left-hand side here, we have a collection of what we called BGP collectors, which are essentially machines deployed all around the world that are listening all the updates from the BGP perspective, right? And the BGP is this protocol, Border Gateway Protocol is, the protocol that makes internet possible. It's essentially mechanism that network equipment uses to actually exchange information about the companies and the prefixes that they own. So if we now look at this particular collector that was receiving certain messages, and we click on show only this monitor to kind of view only what was happening from that perspective, we can see that there were certain events. Would you mind taking us through this event, Mike?
Yeah, so what we can see going on through here, as you said, we've seen some sort of change, some instigation, and effectively what BGP is doing for us, as you said, is actually exchanges information, telling me how I get to it. So if you think of the internet as this collection of autonomous system networks, easy for me to say, this is where we're actually starting to exchange that information. So as we look at this path where we see this change coming through from here, what we're starting to see is as we actually sort of the advertisements coming out, where we were going sort of straight into this downstream provider from here, from a Woody perspective, is we're actually now being diverted and we're actually being advertised out. We're seeing the best possible route for us to get through is to go through this Democratic Republic of Congo based ISP there, who's actually advertising the route out from there to actually get to there. So now we're taking this route. So we've changed from here, and now this is the best way that we're saying to get from this location into, or from this network, I should say, into the Quad9 environment.
That's absolutely correct. And if you look at this, it's actually quite easy to spot what was happening here. With the dotted red line, we can see that this there was a certain withdrawal in the effect, as part of which connectivity between WoodyNet AS42 and the backspace technologies on the left-hand side essentially, got withdrawn. And instead, what's happening is that we are installing different path, as part of which this particular ASN, starts advertising, starts being actually upstream provider for WoodyNet, ultimately leading towards the liquid autonomous system 38844, as part of which, we are speaking about the event that we called root leak. Now, Mike, there are two different types of events that we can speak when it comes to this. The first one is essentially route leaks, and they are hijacks, right? And easy distinction when it comes to route leaks and hijacks are essentially what's the intent behind that, right? When it's malicious, when someone really tries to, take over someone traffic for someone's prefixes, once they are maliciously advertising traffic towards the internet, right? Then we are speaking about hijack. However, when it happens as a result of human error, configuration error, mechanisms, automation-related errors, we are speaking about root leaks. And while it's really hard to distinguish what really happened here, we are suspecting that this was just an error, as part of which we classify this event as a root leak.
Yeah, I mean, it's easy to say, but the characteristics sort of change out from there. But you said the malicious intent between a hijack, and typically what you see within a hijack is that path maintained. Here we saw a complete loss of connectivity. We couldn't actually get to this service. What we've seen in hijack is this diversion, is exactly what the word says, what it says on the label. It hijacks it, and it's going through this different area there or to a different network, which for the malicious intent there.
Exactly. And the other thing that I wanted to point out is that if you hover over the collector on the left-hand side and you actually click on view details of the path changes, the thing that you can see quite clearly here.
Love this view.
Exactly. Like you can actually see what was the initial path, and we can see that the path was originating ASN, then Woody ASN, and the target of the ASN where our collector is essentially located. And then you can quite clearly see that at 12:13:01 UTC, so what you're getting is exact timestamp of the event when it happened. We can see that longer path, which is quite interesting as well. gets installed. If you think about it, BGP as a protocol prefers the shorter ASN paths, but in this particular case, you can see as a result of this root leak, the way that prefixes were advertised towards the rest of the internet, a longer path got installed and traffic got diverted, right? So now we see that actually, we see what was the contributing reason to 100% packet loss that we were seeing in the path visualization for Chicago, Los Angeles, and some other regions, right? And then we saw how all of that contributed to, service impact from the DNS server perspective. BGP was initially not designed with the security as its guiding principle, which is unfortunate, right? And there are certain things that over the years, certain companies and individuals tried to push as a best practices. One of the things that we need to speak about is RPKI, or Resource Public Key Infrastructure. Would you mind telling us a little bit more about that, Mike?
So the RPKI is in very simple terms is really, do I trust these routes coming out from there? So I'm signing my routes. This is all my networks. My prefixes are coming out from here. So they're authenticated effectively as you go through from there. And then you're also checking for those authentications coming in. So these are trusted routes. These are trusted advertisements. You're allowed to advertise these coming out from there. That's really in a nutshell.
Exactly. And before we started actually speaking about this event, I actually checked, and Quad9 as a company, they actually sign all of their prefixes, which means that if the companies or their upstream providers that actually let this happen were enforcing RPKI verifications or filtering, as part of which, if you are not the owner of if you are not the if you are advertising something that you are not signing, they would have dropped you. And, even though they had them signed, the companies, upstream companies, in this particular case, Liquid ASN, who propagated this further, right, unfortunately did not filter the advertisement, as a result of which we see what we see. Now, it's kind of funny to see, during the preparation for this call, I was actually checking some of the prefixes from the Liquid ASN, right? And it's really interesting that themselves, all of their prefixes are also signed with the RPKI, which means that they want to get the benefits of the RPKI. However, they are not filtering prefixes themselves. So, they are saying, we see what's the benefit in using RPKI, but we still haven't decided to actually take that step, as part of which we are going to filter prefixes that belong to someone else, right? It's like last missing step, right? The other thing is, like, this goes to speak about, other things such as improper filtering. So, for example, many companies, even before you end up peering with them, are going to have really strict requirements to have your all prefixes in peering database, for example, and stuff like that, right? As part of which, if it's not in there indicated with correct objects and stuff like that, there are certain rules there. They are not going to even accept your advertisements. So if the prefix is not explicitly on the list of prefixes that you should be advertising, they're just going to filter you, which goes to say that, operational practices could be improved. And thankfully, there is this thing called mutually agreed norms for routing security, or manners for short, which actually lists all of these best practices and operational practices that companies should follow. And, companies such as Cloudflare and others on the internet are doing really good job of, making sure that participation year over year gets better, that companies join, but I think there's still a long way to go.
Yeah, absolutely. So on that theme there, I mean, Quad9 did a pretty good job, I think, of actually letting us know what was going on. They were quite transparent about saying what was coming out from here. And I think, to your point, they're actually sort of pushing the mannerist stuff there as well, and saying, this is what we want to do around from there. But it's an uphill battle, I guess, in trying to get sort of everybody on board to do that.
Yeah, it's going to take time. The thing is, like, as we said, when BGP was designed, security wasn't their guiding principle, right? So having a security as the afterthought, which we saw even in coding practice and stuff like that, always tends to be a really hard thing to do, right? So because it's opt-in, we kind of get to see the negative effects of things such as root leaks and hijacks from time to time. Now, if I go back here and if I click on the path visualization, Mike, here, we briefly spoke about these purple lines on the timeline, right?
Yeah.
So actually, our Internet Insights also captured this event. Could you actually take us through what was happening here?
Yeah, this is really cool. I like this view here, and we come into there. So as we said up front, is when we're looking at those purple swim lines there, it's actually identifying. In this case, we had a network outage. So although we're looking at sort of a smaller duration, you can see it started at the same sort of time. So what we're looking at from here is we're looking at sort of subset of agents. You can see in the middle again where we have that the autonomous system there is this is where we're having this outage there. And from an Internet Insights perspective, a network outage determines 100% packet loss across a number of tests. Like I said, to have an impact themselves. So if you drill into that from there, what we can actually go down to is to start to see specifically where those interfaces were actually pulling that information from. Sorry, where the interface is actually stopping, where we start to see that forwarding loss occur from there. We can see all of these are occurring within the liquid telecoms environment there. We can actually start to see that. And if you look across to the right-hand side, we can actually then start to see the impacted customers. So we can see the likes of Quad9 coming down from there, and then their downstream provider. Yeah, great. Will do, Kemal. I love this. I love this view. I spend my life in Internet Insights. So essentially what we're actually looking from here is we're saying, as I said up front, that purple swim lane there indicates we had a network outage. We see we've gone across from there. What we're looking at there is the actual interfaces impacted. So that red block up there tells the interface impacted. And if we drill into there, we can actually see the location. So we're seeing here where the forwarding loss was actually occurring here and down to interface name. So we're seeing that in liquid telecoms environment there, and we actually got the interface names. This is all public domain information. You're also seeing where we're actually impacting the downstream customers. In this case, the Quad9 and the WoodyNet, who happens to be their downstream peer, would actually come into there.
That's pretty awesome. The other thing that's quite important to notice is actually having the real visibility into this, whether it's from the Internet Insights perspective or whether it's from the path visualization, BGP alerts, and stuff like that. I would say it's a crucial thing to have, right? And not only visibility comes and it kind of like importance is self-evident in this particular case, but also having capability to alert in a timely manner about these events, and having the ability to have your NRE, network reliability engineering teams, or DevOps teams, or SREs, depending on how your organization is running, or just regular operations team, having dashboards views of these events, in my opinion, is really important.
Absolutely. You can't overstress the visibility across from there. A picture paints 1,000 words. I've said this on this podcast a number of times. I'm a very simple person. I like to look at a picture what's going on, and we can see very clearly what was happening from here, from that macro view down into the micro view, to see how it's impacted me going across from there. And all of that, if we talked about it briefly, the concept between the route leak versus the route hijack from there, understanding that path, simply, do I have a high loss rate? But it might even just be a latency increase because I'm going through 17 different hops now because of the way my network's been advertised. And just visualizing that straight away, you can see where I'm going. So I can do two things. I can start to mitigate my service, mitigate the problem by taking another action, re-advertise my prefix or whatever happens to be, or I can plan for the future to get around that. So this is not going to happen to me again by splitting my prefixes or whatever.
And that's actually quite a good point. In this particular case, if you look at the BGP route visualization, and for example, if you focus on to this particular monitor, right, you can actually see that the operator was advertising /94, right? So
24/24.
Exactly, /24, which is really important, right? If you think about it, that's the smallest prefix is going to be accepted on the public internet, which means that Quad9's hands were tied when it comes to what they could do from the traffic engineering perspective, right? So having visibility, which seems that they had, to be perfectly honest, but having visibility is crucial, right? So for example, in this particular case, given the fact that your hands are tied from the traffic engineering perspective, the only thing that you can potentially do is pick up your phone and call the provider and tell them, right, like this is you are doing this to me, like, and this is affecting my reputation, my revenue, and everything that goes with it. So this again stresses the importance of having visibility. And you already outlined that point, and I could not agree anymore.
Yeah, and it's visibility in real time, or visibility. We've seen this immediately as happen. We talked about the light switch moment when it goes on and off. If I'm relying on even an update from Twitter or an update at a status page, I'm essentially going to be behind the 8 ball. I'm going to be looking, whereas I could immediately see it. And the benefit to that is for future occurrences, I can have some automated process that's going to kick in. As we've seen across a number of customers over a number of years.
Exactly. Mike, it's been my pleasure speaking to you about this event. I think we uncovered what really went on here. Thank you so much.
No, it's always my pleasure, mate. Again, we could talk for hours, and we can see people sort of trying to wrap it up, but that's good. So that's our show. Don't forget to like and subscribe, and if you do subscribe, we'll send you a free t-shirt. Just drop a note to internetreport@thousandeyes.com with your address and t-shirt size, and we'll get that straight over to you. Thanks very much.